All right, they're not too hard, not too bad. All right, so half-lives. All right, every radioactive or radioisotope decays at a specific rate. All right, so a half-life is decaying, where everything decays. Okay, and it decays based on the half-life. And this is the definition. Okay, a half-life is the time required for half of the atom in an unstable isotope to emit radiation and decay. Okay, so everything we're just talking about decaying. All right, so the time required for half of the atom to decay. Okay, that kind of makes sense, right? Time required for half the atom to decay. All right. Now, if you look down here, I start with 10 grams of radioactive material. A half-life would be the time required to get to 5 grams of material. A second half-life, so let's say we went under 2 half-lives. What's half of 5? 2.5. Okay, and then so on and so on and so on after various half-lives. Okay. So if we look at this, nitrogen-13 has a half-life of 10 minutes. It undergoes radioactive decay and turns into carbon-13. Okay. How long would it take for 4 half-lives to pass? All right. How long would it take for 4 half-lives to pass? So what I'm actually going to do here is I'm going to try something out. We're going to set that up, do that small screen, slide that over. Gonna see if this works. Brought my projector home. Trying to load it up. There we go. Let's zoom in a little bit. All right. That looks upside down, doesn't it? Oh, man. Let's see if I can turn it around. There we go. Now I just got to zoom out a little bit. All right, so hopefully y'all can see my piece of paper here. All right, and still see the PowerPoint slide over here. All right, so we were right here. How long would it be to have 4 half-lives pass? Well, if my first half-life lasted 10 minutes, how long would it take for 4 of them to pass? Well, your answer should have been 40. Okay, your answer should have been 40. All right. Number 2, let's look at another type of problem. If a sample started with 2 grams, so if I start with 2 grams of nitrogen-13, how many grams would remain after 3 half-lives have passed? So after one half-life, so after my first half-life, how many grams would I have? Well, half of 2 would be 1. So that's 1 half-life. Let's do another half-life. What's half of 1? 0.5. So that's 2 half-lives. Let's do one more half-life. That's what the problem says, 3 half-lives. So what's half of 0.5? 0.25. And that should be your answer. Okay, that should be your answer. Okay, so hopefully that kind of makes sense on half-lives. Okay, let's try one more. Let's try one more. How many grams of carbon-13 will exist after 3 half-lives have passed for the same sample mentioned in question 2? All right, how How many grams will exist? I want you to try it out. Okay, so this is how you solve it. I started off with the nitrogen, all right? And I started off with nitrogen. Hopefully you can see my paper. And I turned it into carbon, right? That's what my problem said. Nitrogen has a half-life of 10, and it turns into carbon. So nitrogen goes to carbon. So if initially I had 2 grams of nitrogen, and I finished with 0.25 of nitrogen, I should do that, 0.25. The question said, how much became carbon? So if it went from 2 to 0.25, how much of it became carbon? Well, you got to subtract those two numbers, and you get 1.75. That's how much decayed, right? That's how much decayed and became a new substance. All right. Is there any questions? If you have a question, just feel free to unmute and please ask. I would love questions. Okay. All right. So I want you to try a problem out. All right. Try a problem out. I'm going to put this on the big screen and then I'll show you how to solve it. Nitrogen 12 has a half-life of 2 minutes. If a sample started with 60 grams, how many grams of the original material would remain after 4 minutes? The second question says, how many grams would have decayed into the new isotope? So there's 2 questions here I want you to answer. All right, 2 questions I want you to try out. I'm going to give you about a minute to solve this. Try to get it. Okay, let's try this out. So I know nitrogen has a half-life of 2 minutes. I start with 60 grams. I know one half-life is 2 minutes. So the question says, how many grams of this original material would remain after 4 minutes? Well, 2 minutes is a half-life. So what's half of 60? Hopefully you got 30. Then I have to do another half-life. Half of 30 is 15. Hopefully that makes sense, right? Because I had a half-life, and that's my 4 minutes. So now I only have 15 grams. So what amount of the original material did I have? Original material, I have 15 grams left. All right, so that's the first answer. The second question said, how many grams decayed? Well, if you started with this amount and you finished with this, how many grams decayed? Well, 60 minus 15, 45 grams decayed. And that's how you would solve that. Okay, that's how you would solve that. All right, and then I just want to show you what a graph kind of looks like. All right, because half-life is often presented in charts, like on the PowerPoint. All right, so if you look at this, how long is a half-life? If I look at this graph and I ask you how long is a half-life? Well, you look at the amount. The amount is 100. Half of 100 is 50. How much time passed? Well, hopefully you answered 30 years. 30 years, right? And that's the first question. All right. A second question, approximately what percentage of cesium sample would remain after 100 years? Well, you can have two options. You can go to about approximately 100 would be right in here, all right? And if you go over, maybe a little above 10, maybe around 10, or you can do it mathematically, right? So I'm going to say around 10, 12, around 10%, okay? And that's what a graph looks like, okay? That's what a graph looks like. Is there any questions on half-life? Any questions on half-life? I know it's a brand new topic. I thought day one we're going to start with pretty straightforward. There's not too many steps on solving for half-lives. Okay, so I have one thing I want you guys to try real quick, and then we're going to come back together, and then we'll try a second thing. All right, so hopefully you guys have like a piece of paper or something near you that you don't need anymore. All right, because what I want you to do is I guess I could have kept presenting. I want you to go to Google Classroom, okay? And on Google Classroom, I'm going to show you which one. I posted two things. I'm going to show you here which one I want you to do real quick. And hopefully you can see my screen. It's called Half-Life Assignments, okay? And there's two things. There's a practice and an activity, all right? What I want us to do first is I want us to do the activity, okay? So if you click on the activity, it'll take you to this. Okay. Maybe if mine loads. There we go. It'll take you to this, and the directions are pretty straightforward. You need a piece of paper, and if you have scissors, that would be great, but I don't have scissors near me, so I'm just going to rip it. So select a piece of paper from the pile and cut a large circle. Well, I guess I do need scissors. I'll go get scissors. All right. And then after this, follow the directions, okay? Try to complete this, all right? It's just a simple activity showing you what half-lives kind of look like, okay? And when you're done, that should take no more than 10 minutes, all right? So what I'm leaning towards is we're going to come back on the Google Meet about 10:35, and I'll explain the answers to this and how to do the last assignment, and then we'll be good to go. All right, so try this activity out. All right, if you're unable to do it, that's understandable if you don't have scissors, but hopefully you do have scissors. All right, and paper. Okay, so try this activity out. You can either stay on the Google Meet if you have any questions, or you can log off for the next 12 minutes. That's up to you. But we're going to meet back at 10:35, and we'll go over the last thing for class. Sound good? Awesome.